640 times 480 resolution to work with graphically, with 16 colors, and in the end we are going to clear the screen again and reset it to text mode just because it's good practice. So let's run this and see if it gives any errors. Okay, clear screen, no errors. That's what we would have expected. Now, with this screen mode 12, we can actually go ahead and draw, for example, a sun, because we are going to simulate the solar system. We are going to draw a sun in the center with the circle command. And the center is 320 and 240. We're going to draw a circle of radius 10 with color 14. Color 14 should be yellow. So let's run this and check. Oh, I see. Of course, since we clear the screen and reset it again, we can see the circle. So what we're going to do here is an empty loop, but we will be using this later. So do while there is no key input, we will be in this loop. So until we press a key, we will be in this loop and nothing happens. So we should be able to see the sun then. Yes. So here's our sun. But of course, the sun isn't just a circle with nothing inside. It should be filled yellow too. So let's fill it up then. For that we use the paint command, and we need to take a point somewhere inside the sun. So for example, 320 and 1. There's a reason why I'm writing it this way. We will see this in a minute. Then we will draw until we encounter a border of color 14, and we will fill it with color 14. So let's check. Nice. So we already have our sun. Now, the reason why I wrote 320 plus 1 is because I'm now going to put those center values in a variable. Center x and center y. Because I will be reusing them. Earth and Mars. And we are not going to do Jupiter, Saturn, and all the other planets because they are very far out. And we don't have that much screen space here, so let's just focus on the inner planets. In fact, let's just maybe do the Earth and see if it works, and then go from there and extend it from there. So, what we need now is, well, inside of this loop, we are going to calculate the position of the Earth, and we are going to update this again and again. So for now, maybe let's just draw the Earth with another circle command, and we are going, maybe we need to calculate the position. Yeah, let's do a quick calculation. So the x would be the center x plus cosine of an angle we haven't defined yet. Plus, no, times a radius, and the y would be the center y plus sine of that angle times a radius. So, let's initialize maybe the angle at 0 for the moment. Angle is going to be 0. The radius, I don't know, it's going to be 100 pixels. Let's see how that works. Then we're going to draw a circle at x, y. Let's make it smaller. 5 radius, and the color, I think 9 should be a blue or a light blue. Yeah, let's see. Also, paint to fill it out. Add x plus 1, y 9, 9. So this should give us an Earth that's not really moving at the moment because we are not updating the angle. Okay, this looks quite good. We have an Earth at some distance from the sun, and it's not moving, but that's okay. We're going to update the angle now. So the angle is going to be the angle plus some speed. We're going to define it in a moment. removing the old Earth. So yeah, we're getting a ring of Earth. So let's fix that. We need to just draw a black circle where the old position was before we calculate the new one. To basically erase the old Earth. So it's just the same as drawing the Earth, except we're using black as a color. And this should do it. Okay, you can see now it moves. And also it flickers. But that was to be expected, because these old machines, well, they are not that fast. And you can actually see the drawing of the black Earth, then the blue and black and blue and black. And this leads to the flickering. That flickering is actually exactly what I remember from back when I was doing my coding in BASIC as a kid. I also used to do graphics coding, and I always got the flickering. I think there are ways around it, but I'm not sure if it's that feasible with BASIC. So let's keep this for the moment, because it's simple and it demonstrates what we want to simulate quite well. And speaking of simulation, so there are actually, several ways how you could go about simulating a solar system. And what we are doing here is, well, it's I would say the most basic example, or the most basic option. We are now just describing a perfect circle around the sun, and of course, the actual orbit of the Earth isn't a circle, but it's an ellipse, but it's almost a circle. And calculating the elliptical orbit would be very computationally expensive. So you would usually go ahead and use Kepler's laws and solve these equations, and then you get proper orbital motion. And I actually tried this with BASIC, and it's very slow. So we're not doing this, and it won't really make a difference for the resolution we have here anyway. It probably makes a difference for Mercury though, because Mercury's orbit is a bit more elliptical than the rest of the planets here. So Mercury won't be that accurate, but it will still be enough. And by the way, you could even go further and not only do proper orbital calculations for all the planets, but also do gravitational calculations for the planets, how they influence each other, because of course planets don't just feel the gravitational pull of the sun, but also of the other bodies in the solar system, and you could incorporate that as well. But this is going way too far for this simple example, and I don't think it could run on this machine. So we're not doing this, we're just doing circles. Okay, now we have one planet. Now let's add the other ones. year for each planet. So let's define the race. So we have the angle. I would say yes. Oh wait, we need to define the size. So we have Mercury, Venus, the Earth, and Mars, so 4 planets. We will be starting at index 0, so we will be ending at index 3. And we will do this as a single precision because we have really no need, really no need to really no need to do double precision. Okay, so then we are going to wait. Something is wrong. This should single. Okay. Then we're going to need a radius, and let's define that. Well, let's come back to that. But I would define the radius as in relation to the Earth's radius, which conveniently would be exactly the amount of astronomical units these planets are from the Sun, so this is a common measure anyway. Then let's define the speed, but let's define it as the length of the year in relation to the Earth. And I just realized we can have the radius as an integer because we don't have subpixels here. No need to calculate subpixels. So let's also define a standard radius called R. Let's make it, I don't know, a bit bigger, maybe 140. So we can actually see the inner planets too. Then let's define, oh, we need a color for each planet too. I think I can't use the color keyword because it's reserved, so let's call it call 3 as an integer. So now the angle, no, we don't initialize the angle. I guess it's being initialized at 0. Let's hope it's going to be 0. Then the radius for, let's start with Mercury, the innermost planet, is going to be 0.39. These are astronomical units. The radius of the Venus is going to be that's correct. 0.72 astronomical units. The radius of the Earth is going let's just take something 11. The color of Venus is going to be 12. This should be a light red. The color of the Earth we already had is 9. And the color of Mars is 4, which is more of a darker red. So now we just need to update our code below so it runs for each planet, right? Okay, then let's do 4p equals 0 to 3. Yeah, 3. Let's do all of this. All of this. The delay we're going to do in the end. So next B. Okay. I see we also need to have an array of x and y coordinates. So x3 as wait, these can be integers too, right? Y as yeah, yes, like this. Okay, now all we need to do is erase planet P. Erase planet P. Calculate the new position for planet P. At angle B. For our R times the radius of planet P, because R is now our default radius and the radius of P is the vector. Then we're going to draw the planet P. Like this. And we're going to update the angle of planet B with the speed times what do we have? Yes, times the year factor times the vector for the year of planet B. So if I haven't made any errors here, this should actually simulate the whole inner solar system once I run this. So let's have a look. Okay, this didn't work. For one, I forgot to update the colors or to use the colors. Let's fix that quickly. So we have here color 9, which of course is supposed to be color of planet P. Now run it again. Okay, we have a Mars, we have an Earth, we have a Venus, and we have a Mercury inside the Sun. And the Earth and Venus seem to have the same orbit, and Mars is somewhere way outside. Okay, this is clearly wrong. Okay, let's check what we did. So, we have, maybe we need to let's have another look at our solar system and see if it makes sense. So what do we have here? We have the sun at the center. Then we have a pretty fast Mercury on the innermost orbit around the sun. And this seems to be correct. Then we have a Venus between Mercury and the Earth. And it seems alright, the orbit of Venus. Then we have the Earth, and at last there is Mars, and Mars is pretty slow, but it's also the most distant from the sun, so it makes sense. So you can see here, Mercury has a lot of years passed before the Earth even has completed one orbit. And we defined a Mercury year as 88 days. So it makes sense that Mercury is moving around the sun much faster than the Earth is, so this all seems to be correct. Now, something else about the flickering. I mean, back when I was doing basic programming, as I mentioned, I always had issues with the flickering. I had, it just bothered me, because, you never saw games flicker like that, right? So, there has to be a way. So I thought, maybe if you use a proper language like C, and compile your code to machine code, and then it would run much faster, and you wouldn't have these issues. So actually, I went ahead and tried this recently. So let me quickly save this as solsys.pos, and quit QBASIC. And now I also have Turbo C installed, Turbo C version 2. So I try to do the same in here in C. Let me load that up quickly. I guess I have it on C. Sol.C. Yes. So this is basically exactly the same as we just did in BASIC. It just looks more cryptic, because that's just how C is. BASIC is very easy readable compared to C. But you can see we have similar things here. We have radius definitions. We have color definitions. We have an angle array. We have the year. Yes, we have the years. We have the center. We have a speed. Down here we have circle calls, circle drawing calls, flood fill calls. We have position calculations using cosine and sine. We have a delay. So we have all the same stuff, just in C. So let's go ahead and run this. I already compiled it to an exe file. So if you look in here, we can see I have a sol.exe. So this is runs a bit faster, I'm not sure. But to me it looks more or less the same as our basic stuff. And it also flickers more or less the same. And that was pretty interesting, I thought. So it doesn't seem to be much of a benefit to do this in C instead of basic if you're doing it exactly the same way. I mean, of course you could do this much more sophisticated, and if you want to avoid the flickering, I guess you would need to do stuff, similar stuff that games do. So, I mean, what we're doing here is we're issuing draw calls for removing planets, and then another draw call for adding it again. And of course, I suppose, of course, this is going to add flickering if it's running on a kind of slower machine. And games would do this differently, I suppose. Usually the way games work, and I think they used to work that way too back then, is they will prepare a full graphics buffer, and that buffer would then be handed over to the graphics card, and the graphics card basically replaces the whole screen content with a new buffer, and that way you don't have to draw empty or black areas before you redraw something else. You would just hand the graphics card an entirely new screen, and it would get displayed in the frequency that the graphics card is handling screen updates anyway, so this would have been probably 30 or 60 Hertz back then. And that way you could avoid the flickering. And I suppose there would be a way to do this with C at least. But for our simple example, I think this here has to be enough, and I mean, it's pretty cool to do a little solar system simulation with just a couple of lines of code and have it visually animated like this. And this is something you could do even 30 years ago on a computer. And this is, I don't know, this is pretty